All right. Hello, everyone. Shall we get started? Thanks for coming today. There are lots of interesting sessions, so I appreciate you being here. And before we start, I just wanted to say, to me, Svetuk has always felt like more, the conference with this, kind of home cozy spirit, where you have people who are more like your colleagues and people you like almost know and almost work with. And I've been presenting at like a previous conference, and for this one I wanted to make it, really cozy presentation. So this is why I thought, oh, what a great idea! I can draw all pictures myself, so it's like a whiteboard feeling, this old cozy whiteboard feeling. So this all was drawn by me, and I mean this was good in theory, but then I learned that I'm not really good at drawing. So I can bet all my money that an average 5 years old can beat me at drawing. So if you feel that some picture is unclear, what the hell is that, you can just ask me. And I even added some labels on some pictures because they were impossible to recognize. So sorry for that, but I hope it brings you some sort of this feeling of And also, if you have questions or if you don't agree with something, feel free to ask. I want it to be, the room is small, and I think it's perfect for this kind of presentation. So if you want to discuss and turn it more into discussion, feel free to do it. So yeah, and then let's get started. And I wanted to get started with a car. This is a car, right? Does it look like a car? I hope, yes. And talking about the car, let's say Tesla car, right? If you are a manufacturer of Tesla car, you have to assemble it from many components, small components, big components, and you need to know where all these components are coming from. You need to know what type of the small screw is there. And if you are asked, okay, how many components do you have? What types of them? And you can provide them the entire listing of every single small detail. And even more, let's say there is a screw, and you learn that there is a screw, and the provider, the supplier of that screw, screwed up, and there is this tiny red line on it where it just falls apart if you start using it in a car. So this screw is vulnerable, right? And then if you learn that, what would be your next steps? You would immediately replace it with the screw which is not screwed, with the normally working screw. And this is normal for manufacturing. But sometimes I see the software dependencies, they're treated a bit differently. If we know that the software dependency is vulnerable, we say, well, we have technical debt. Yes, but think about screw in the car. That would get replaced immediately, no matter the cost. So my point to start with is that dependencies of software are like car components. So they make this whole thing, the big car, function. If something is wrong with the dependency, it doesn't matter the car stops working, but it brings some threat, it brings danger to working with that, for driving that. So would you drive a car if you knew that it has some malfunctioning, badly designed screw in it? Well, maybe you wouldn't be so willing to do that. So, and if we just move forward, let's say every component is some sort of library, and before making a decision about a component, you can ask yourself, if my software was a car, would I handle this particular component this way? And then you can compare it to how you would handle it if it were a library in the software, right? So, and I felt before that I had this perception that the dependencies, they're underestimated, their importance is underestimated. And I'm here to change this perception a bit and just bring some more light to particular points about dependencies. So, before we start, just a few words about me. I work for Snow Software. You may have heard of that company. We're based here in Stockholm area. I'm Director of Engineering Security as of now. Previously I worked for Nokia, Microsoft, GE Healthcare, and I participated a bit in the developing of WASP dependency check tool. Have you heard of a WASP dependency check? Cool. One hand, two hands. Nice. So I'm a bit subjective. You'll hear more about this tool, but it's just a small participation. So this is about me and about this talk. So I wanted to avoid, focusing only on vulnerabilities. Because when we think security, we think vulnerabilities. But security matters in many more different areas. Let's say, what if we talk about open source components that we use? There are licenses that you don't want to be in your proprietary products, in your commercial products. There are other things that are related to having no control or visibility into your dependencies, like the car, and you don't know where this wheel is coming from. Is it from Korean manufacturer or from, I don't know, Chinese manufacturer? Well, it depends on the version of the car. So this talk will be built around that. But before going into details, really quick, really basic introduction to .NET dependencies. And I learned that, when you have this kind of 101, sometimes for yourself, it's like this aha moment. That happened to me many times. Like somebody says, this is really basic stuff. And then I learned, okay, this is I didn't know about that. So hang with me. Don't go away yet. More exciting stuff coming. So how do we manage dependencies in .NET? So today, officially old way is having them listed in packages.config. So how many of you have projects that use packages.config for storing dependencies or information stuff? Okay, so more than half. Cool. So that's exactly like how packages.config looks like. If you can read, it's just XML format where each entry describes a particular package. So good old way works perfectly fine. Microsoft, however, came up with the new way, which is package reference format. Anyone using package reference? Okay, less number of hands, but good. And yeah, they write that it's not fully compatible yet with C++ and ASP.NET projects. And the difference is that we put dependency information in the project file. Here we have it. We have an item group, special item group for package references. And pretty much in the previous slide we had development dependency. Here it says private assets. It's pretty much the same. So it's similar, but it's different. What are the advantages? Why Microsoft wants us to start using package reference? Well, first of all, of course, it's integrated in the project file itself. So we have one file less to manage. It's versioning. There are some differences in version. You can be more specific or more general. It gives you more flexibility over versioning and how you specify what version of dependency you need. And also it supports conditions for dependencies based, let's say, on target framework. Just recently they added support of log files. So the generation of log files is supported in one of the latest Visual Studios, and it's pretty much like any other log file, like in NPM. So it gives you a snapshot of dependencies, and you can be sure that this is what the project was like built with. And finally, interestingly, it gives you a top-level view of dependencies. So it doesn't go into dependencies of dependencies of dependencies. So it keeps it a bit smaller, the list of them. So, and final point is that it's under active development. So it's not forgotten, it's not abandoned. And with packages config, like all new features, they're coming here. They come into project reference, package reference, instead of packages.config. And talking about versioning rules, the changes, or like how you can specify versions in package reference. So you can start using the intervals. So it's pretty much like mathematical intervals. Same rules applies. So for example, here we have all the versions of this package from 100 to 200, excluding these versions. So excluding like the ranges of intervals. This one with the square bracket, it's including 200. This one is including both ends of this interval. And finally, wildcard support is added, so it will be like any patch version of 1.0 point something. So, and this supports like the semantic versioning. So we have major, minor, and patch version symbols or number for those things. And with this versioning, there is one thing which makes not that much sense to me. Look here. If you got package reference for Newtonsoft.json version 901. What do you think? What version will it be actually resolved to? It will be actually resolved to any version starting from 9.0.1 with the preference for this one, but not necessarily. So if your source of packages has no 901, it will try to find the next version and the next version. So it's like, if I say 2 equals 2, I expect, to be true. But in this case, this equality, it doesn't mean exactly what it means. So like pitfall here is, let's say the package source is unavailable, or you have multiple package sources. One of them, let's say your NUGET.org, is unavailable, right? And you have another package source which has another version of this. And then you can accidentally ship a wrong version, or the version you don't expect, to the customer as part of your product. So to make sure you don't fall for that trap, you need to use like the interval brackets here. Well, whatever. That's our life now, right? Moving on to JavaScript dependencies. I'm sure there are some Razor View gurus here, Razor Pages, all this cool Microsoft stuff for front end. But mainstream development went to JavaScript, and if you check Stack Overflow, the most popular language, and so on, so JavaScript is everywhere. And how many of you have the products with the JavaScript front end? Wow, like almost everybody. Cool. could went different way. Then I don't have to tell you much about NPM, how NPM handles dependencies, except for, yes, I mean they are part of package.json file, and they're specified as JSON format. But the version in here you say I want Vue 252, and you get it. You don't get anything higher than that with the preference to this version. You get the exact version. This makes more sense to me. And then instead of intervals, you have tilde for any patch version. So for the last digit there, you can get open interval saying anything higher than that. And you can get any minor version, so 8.1 would go, 8.3 would go, and so forth. So yeah, makes sense. New tool for JavaScript files, for libraries file. How many of you have heard of libman? Oh, cool. So libman, it's a new Microsoft built tool. I think I first learned about it somewhere in September last year. And this is used for managing client-side libraries without bringing all this, framework, Node.js stuff on board. So it's pretty much, if you use Visual Studio version 15.8 P3 or higher, when you create a web project, you can right-click on the project after creation, and there will be this manage client-side libraries. This would bring libman functionality on board. You will have to install a NUGET package for libman, which is like library manager, and then you will be able to manage client-side libraries. There will be like small window, I can demonstrate later. There will be a small window saying, okay, which library do you want to bring? Where are you bringing it from? You're bringing it from a provider. In this case, it's CDN.js. CDN.js is just a big collection of libraries, just like big feed of JS libraries, like such as jQuery. And whenever you need just a library, let's say minified version of jQuery or something like that, you can use libman, and then it specifies where to restore it. It creates this folder structure. It creates, more importantly, libman.json, and this is the content of this file. So as simple as that. Why you need it? Well, when you only working with library files, as I said, when you don't want to bring all this powerful but kind of computationally expensive NPM Node.js functionality, when you just need a jQuery for yourself. And yeah, it supports not only CDN.js, it supports on package source and actually any URL. So it will just go to that URL and try to find this library there. So you can try it out. It's Microsoft made. They promise to make development go and don't forget the tool. And I know I've seen some good reviews about it on their comment pages, so people liking it. So I thought, why not to include in the presentation? So I hope it helps. All right. Now, I think a beautiful drawing, right? Why bother? I mean, we have so many great tools. Why didn't we make the dependency management great yet? Or why it's not that simple yet? Well, there are a few key challenges before we can make it happen. So first of all, it's always about deciding whether we want more control over libraries or we want to get latest features, right? So it's hard. I mean, there is no right answer for that question. It depends who you're building product for. It depends how product works and so forth. Another challenge is everybody can find issues in JavaScript libraries or in NUGET packages, but it's important to find issues before it's too late, before the library was sitting there for 2 years and God knows what was happening while it was vulnerable, for example. And finally, it's also important when you think about dependencies and challenges about them to avoid open source licensing trap. I'll explain what I mean by that later. So first we go into the control versus latest features. Let's say we have two cases. Let's say in one case we don't fix the version. We say anything higher than 5 works for me. Whenever there is 5.1, 6, 7, we just go and we install it automatically. So this is your npm or your NUGET or like package reference file. So the plus of this, the good point, is that of course you get the latest features of the library, but there are a bunch of downsides. So you get vulnerable to supply chain attacks. So who knows if the newer version is using some sort of dependency which is vulnerable at some point. You don't know that. These libraries, they may introduce breaking changes. So you may break the functionality with that. And the project inventory becomes dynamic. So the project you released yesterday and the project you release tomorrow without any changes to code may become dynamic, right? So you may release different versions. And this is funny. If I go to Visual Studio and if I create a new .NET Core project, it creates a package references for me for projects, and then for the core .NET Core library, it doesn't specify a version. And I'm like, really? So yeah, it may happen, and it's happening more often than you may think about. So let's look at what if you fix the version, like fix the version correctly with the brackets. Of course you get the version you wanted, but the problem is, let's say 2 years from now, it's the same version, right? So you may stuck with older libraries. Maybe, I mean, because it requires more maintenance and review. You need to review, okay, do we want to switch to the newer version of the library? And like manual effort, right? And it's easy to forget something in the configuration like that. And finally, very importantly, old libraries, they also get new vulnerabilities. So something new is discovered in the old library and the entire project becomes vulnerable. How can it happen? This is exact example of the supply chain attack. Let's say you have your project, it has dependency of, it has also dependency, and then the dependency of the dependency of the dependency becomes vulnerable. And then through that particular library, and let's say here they will specify the open interval, right? Through that particular library, the entire project can become vulnerable. And this is what we want to avoid. So how can we do that? In a way, I come up with magic formula. It's almost like as magic as my drawings. So it consists of sufficient control, the key is sufficient, automated checks, and regular review, when you don't forget what's happening with your dependency stack, with your inventory of the libraries. So what is sufficient control? This is a CCTV camera, by the way. Yes. So the sufficient control should answer, we should build a process which answers the questions at any point of time. What is the library? Including the version, including what are we bringing on board, right? It should also answer the question, where is it coming from? Is it coming from trusted source? Is it coming from the local feed? Is it coming from internet every time we're building a project? Because it happens. Sometimes some projects, they just keep downloading libraries. And if you go to NPM, you can see millions of downloads for particular libraries. And most of them are coming from CI systems which just keep downloading them every single time they need to build. And finally, the question: is it good? Is this particular thing that we are bringing? It's supposedly good, but is it actually good? So we need to check that. So how can we make it happen? Well, I would say we should prefer intervals, specified intervals, over the latest version. So, I mean, specifying the open interval, saying, okay, bring whatever, it may backfire. Unless you have really small project and unless you don't really care about it, I believe there could be some cases of that. You can, and this is very important, in the next slide I'll show more, you can now verify package signatures for NUGET. And this is really big thing to me, at least, to discover and to start using. So now you can at least know where is it coming from, that the source is valid, maybe. It's okay to be one minor release to the latest, so just keep doing the due diligence when updating the libraries. So it's okay to be one version to the latest. It's okay to be on the latest version if it's your choice, right? So I think the important is like to make it your choice and not the choice of the interval you specified, saying anything else higher than X. And the nice idea sometimes is to have a local feed solution or local provider solution. I'll show more about like what are the alternatives and why it's bringing value in the slide after this one. So first of all, using signed packages. In the very recent, one of the recent NUGET versions, I read 4.6 also started supporting it, but somehow semi-officially. They added the verification for signatures for the packages. So from now on, the packages can be signed with the author certificate or with the feed certificate when uploading them. So let's say when you go to NUGET and when you fetch a package from there, it says, okay, this package has a certificate from, well, pretty much there was more information, but this one was from for NUGET.org. So this is package from the valid source. This is what we can verify. And if a package has no signature, the verification fails. And that can be done with NUGET Verify. Here there are two types of signatures. There could be a signature for the feed, saying this package is coming from NUGET.org, which is only half of the problem, which solves half of the problem. We verify the identity of the source, but we don't verify that package wasn't tampered with. Because what if somebody hacked, I don't know, the repository and pushed the package to NUGET.org like a valid package, but put wrong code in it? So then there are packages that sign with author certificate. And let's say then you need to trust explicitly the author certificate, the public key of the certificate. You need to add it. There is a functionality to add it to your trust list. But here, let's say you have 20 suppliers of packages, then you need to trust 20 certificates, and those certificates may expire at some point. So it brings lots of overhead. I'm not sure how they're going to solve it yet, but it's a first step in that direction. NPM doesn't have it yet. At least out of the box. And NUGET didn't have it for a while, and everybody was like, why? But now they start, and I'm really happy about it. I think it's a big addition to the ecosystem functionality. Right, so if you have time, you can explore. Here's this. So you'd say you restore the package to a particular folder. We assume this is configured by default to the latest, to the current folder, and then you say NUGET verify signatures, and you specify where new pkg file is, and then you get the output as I got. And by this one, you making it this verification required. So whenever you do restore, it would also automatically perform the verification. Maybe don't do it yet because not all the packages support it. I tried it with autofag, and that is not signed, for example, and some other packages not signed. But it's a new functionality, so you can explore. All right, few words on local feeds. You can have a local feed like a server's packages, pretty much, and with some web UI. It protects against outage of the main source. How many times your development was stopped because NPM wasn't serving packages? Did it happen to anyone? Okay, come on. It happened to me. Yeah, but just in case, if you rely in your build system on some sort of, like every time you go and fetch, it may backfire. And then if you have a local feed, like a proxy between the source and your build system or your machine, that can help. It can help optimize performance by caching packages, and it can give you more control depending on the features, on the functionality of the particular tool you're using. And what are the options out there? There is NUGET.server, the official Microsoft feed solution. It's pretty basic. It just, it's like IIS application which stores files. There is ProGet. ProGet is semi-paid, so you can get lots of functionality for free. And this supports like connecting to a remote source, and then it supports like caching, which is good for performance again. And there is MyGet, and it's also paid, and it supports similar things. In the paid versions, you can also specify which licenses to bring, like bring more policies on board, saying we don't want this license even to be in the company premises. So you can play with that. You can look which functionality is there. And how it works is pretty simple. Let's say you want to restore the package, you specify your local feed, then the feed, there is no package like that, it requests the remote package, then it gets it and caches it, and then it delivers it to you. So simple but powerful concept. Helps you enable more control. Now, if you remember that table, the second, or let's say you implemented all of this or part of this, you're happy now. What's next? Next, we want to enable automated checks. Why do we need automated checks for dependencies? Let's say you want to bring a new library and it passed all the security reviews, you did amazing amount of due diligence, good job. You introduced dependency, right? But then again, some point after, vulnerability discovered. And you did reviews here, vulnerability discovered here, you didn't watch some sort of, intelligence, threat intelligence feeds, and you just continue using it when it's being vulnerable. So to prevent it, we need some automation in place to just check how bad is that, the situation with our libraries. And when I think about automation, I always think about this robot. This is the angry robot, and this robot only has two modes, no and yes. So this automation in place, it shouldn't have like any gray zones. It's like, yeah, this kind of good release, but well, these libraries, there are warnings for you. No, not like that. It's either yes, perfect, or no, something is wrong, go do it again, or go change the problems, fix the problem. So it should be like really cool robot. And which tools can we use for .NET and for doing this analysis? There are three tools I put here, and this is first one is called DevAudit, right? And it's the basic tool. It's just a batch, or not a batch script, the binary. There is, I think it's like 10 megabytes, the entire solution, and it's free, and it supports .NET Core, it supports NUGET packages, it supports some other checks, and you can fetch it from GitHub. So what's so good about it? Of course, it's CLI based. It's literally with this command you can run the check. So it's super simple. However, the intelligence is based on the feed managed by Sonotype. Sonotype is the company behind SonarQube. They claim it's good quality, but I think the private intelligence feeds for vulnerabilities, they're usually a bit more, they have more information and they may get it quicker. But this feed is kind of okay, it's reliable. And finally, to get the information of vulnerabilities, like get the, JSON file or some sort of structure, like PowerShell structure, where you see what vulnerability, what severity it has, you may need some output parsing scripts, because it's not so great at building this, structures. Yes?
What's the last vulnerability you found in the NUGET package?
Last?
Yeah. Or the first? Or have you ever found a vulnerability to one of these feeds?
Yeah, absolutely. Yeah, I can show you.
Like a serious vulnerability? Or?
Yeah, if you go, for example, .NET Core 2.0.0, it has like 12.
Okay.
Yeah, and yeah, sometimes we found we were using it for ourselves in CI/CD, and we found there was some sort of HTML parser, and there was a new vulnerability like reported in October, and we found it in November. So I was like, yeah, this works actually. Yeah. So, and to get it to work, it's just, let's say you have this file, right, with package references. This is where I was looking for something to bring me results, right? I added this line sp.net core all, and then this is the output. It gives me 12 known vulnerabilities. Yeah, and the line is like, it's super simple. Just run it against your CS project file, and it gives you that stuff, and it gives you error code 1. This is all you need for that robot, so it says no to your builds. And however, this part, if you want to parse the details and put them somewhere else, you would need to parse entire text, which is a bit not convenient, I would say. However, Dev Audit has the developers of that went forward, and they made an extension for Visual Studio, and I think this is big. It has only 1,800 downloads on Visual Studio Market, which is nothing, pretty much. So we can add another 50 today. Yeah, it's pretty much you install the extension and then it starts auditing everything automatically. So when you restore the package, or when you just do that, yeah, like NUGET restore or build, you get the output. And this is how it looks, the context menu. This is the addition, and this is how it looks if the package is not right. Let's say this .NET HTTP is wrong, and then you get a problem with that. So you get errors. Awesome. So I would say this is, especially if you're working with a solution which has no technical depth at this point, no known vulnerabilities. And even if you work and you know that there are vulnerabilities in libraries you use, then you should replace these libraries. So you can go there, install it. I think it's adding a lot of value. Okay, another tool. Now we're moving towards the more powerful tools that can generate reports and some cool things for you. So this is a WASP supported tool. If you go to a WASP site, if you manage to find anything there, because their site is a bit of a mess, and they have so many tools. Some of them are half-baked, some of them are amazing, and I would say this is an amazing tool. So it's dependency check. It's very powerful. It supports almost every stack, and unfortunately .NET is a bit on the weaker side of support for dependency check. So Java is the best, and if you program in Java, definitely look at this tool. But still, .NET is okay, and it generates cool reports. It can work with anything. It can connect to private intelligence feeds, like from Nexus, for example. Yeah, and unfortunately, it takes some time to set up, some time to filter out the wrong inputs, and it also is sometimes generating really strange false positives for .NET. They say they're working on that, but if you run it for the first time, you may see some questionable inputs or outputs. So, but still, you can give it a try. And how to give it a try? This is the line you need to run it like, right? So it's a bit longer than the previous tool. But what it gives you in return, it can generate anything like JSON files. It can generate bill of material files, like for consumption by other tools. It can, in the reports, you see a lot of different information. And what is important, it generates full list of vulnerability, full list of dependencies as well, not only vulnerable. Yeah, and you can even suppress some vulnerabilities for the future use. So let's say if you want to run it again and again, and you know that this is false positive, or you kind of okay with it, you accept the risk, then you can suppress it. So a good tool, a bit harder to learn. But on another positive point of it, it integrates very well with another WASP-backed tool called Dependency Track. It's for tracking the life cycle of dependencies. It's also open source, it's completely free. There is no enterprise version of that, so it's like pure open source. And you see, if you have many projects and you need to see the progression and you need to track them and show your management, some nice charts, whatever, just you can use it, yes. But again, it requires some time to set up, maybe a day or so, just to set up this integration and how it sends files and how it works together. Alright, moving on, since this was for .NET, and actually I have to mention that the dependency check, it also works nicely with JS dependencies, JavaScript dependencies. However, NPM just recently got its own nice new security feature. Have you used NPM audit? Yeah, that's pretty cool. How many have used? Or how many of those who have JavaScript didn't use NPM audit or didn't hear about it? Okay, some. Cool. So NPM acquired a project called Node Security Project in, I think it was May 2018. And the project was pretty much JavaScript library, which was analyzing your packages.json if there are any vulnerabilities. And it had its own feed of intelligence. It has its own vulnerabilities list. And starting from NPM 6 plus, they integrated it. They made NPM audit command, so you don't need any tools. You just need to run NPM, and even when you install stuff, it runs already. So it's hard to miss if you have NPM 6. But to get the details like this, you need to run NPM audit. And still, like, I'm not really happy with how you can parse the results. So you can generate files, but format is a bit weird to me. But with some sort of mumbo jumbo and efforts, you can parse them very well and then use them for your, like have some vulnerabilities database inside of, your product. So NPM audit is really great, and if you don't have it yet, just update to NPM 6 plus. Commercial tools, just to mention, if you are like really serious about dependencies and have a lot of money, look at them. There is WhiteSource, Black Duck, and Snyk. Snyk is very known for JavaScript stuff, but it also works with NUGET packages. I'm not sure how good is that. I never tried it with NUGET, but I think you can even set up for GitHub projects. You can set up a free integration with Snyk. Yeah, they're powerful, but expensive. They're like expensive. Like, well, you never know, because you have to compare them. Like, you have to pay the full license and then see what finds better. They say both of them have, well, 3 of them, they have their private feeds, which they pay lots of money to people to manage them. So, well, they're supposed to be better. Yesterday I got email from Sonatype, the company behind the feed for free for dev audit and everything else, and they just wrote that their feed is good. That was the main message of the email, and I was thinking like, it's a good timing, really. So, and they say that they have publicly available information, so I think they scrap internet for vulnerabilities information, and they have some sources where they scrap it from. So here they have people sitting there. So I don't know. I think automation will win at some point, but now maybe it's people. I don't know. But they also provide all this like dependency track-like capabilities where you can have entire policies, entire overview of your all projects, so which is good. Okay, moving on. I think we don't have that much time left, unfortunately. So in this case, whenever you build something with those tools, always integrate with CI/CD. Otherwise, like, why bother? Why doing it? Like, why doing it one time? Remember the timeline where you did it once and then it didn't help, actually. So run on build time. If you add 5 seconds to the build time, okay, why not? Check all commits. Well, check everything, so nobody sneaks anything there. Or, well, at least check your merges to master. I think another talk in one of the big rooms is like, we commit to master. So check commits to master too. And then pull the plug. If something goes wrong, just exit code, not 0. Just stop it. Just don't let the build progress. Okay, very important topic. On the other hand, okay, we leave the vulnerability space. We go to open source space. And this is, you see, this is a trap, and this is the open source sign in the middle. That's important. We will see more of that, okay? Why do we need to avoid licensing trap of open source? Because different open source packages, they actually license differently. So open source is not the same between the packages, right? Openness is different. So sometimes there are strings attached. Yeah, I know. These are wheels of the Trojan horse made of open source. And why I put it here? Because this is exactly what can happen to your project. If you bring and distribute a library or as part of your project, which is open source library, but which has a license, which called copyright license instead of copyleft license, you may be forced legally to open source code of your entire project, and you don't want to go to your director of engineering or I don't know CTO and say, well, now we have to, you know, open source our proprietary code. Yeah, kind of bad thing. So how to classify licenses? I came up with this. I think it's beautiful. There are good, bad, and ugly licenses. So good licenses are those that you don't care about much, that you can just bring them in. MIT licenses, one of the examples. I will give you more examples in the next slide. The bad licenses, GPL. That's what we should avoid. I mean, I read the Stack Overflow reviews, and some people just start putting minuses to those who say avoid GPL. But I talked with our legal guys a lot, and they say avoid GPL. We don't want GPL anywhere closer to us. And then ugly licenses, like surprisingly public domain is ugly. Free to use is ugly. Because from the company point of view, it's better that you know how to use a library rather than it's, you know, some sort of free to use, but nobody knows how, like who is liable and how to track that, how to interpret that. In different countries, public domain is a different thing. And this guy, this tough guy, tells us also do not forget to put attributions to your to all the libraries that you use. For example, with MIT, it says it's free to use as long as you put this part of the license file somewhere with your application when you distribute it. So don't forget doing that. And now, like a giveaway for this presentation, this is the table that we came up internally after the legal consultations. What can we use, what we can use but never modify. The source code, let's say if we bring in the library but no modification. And this is what we should avoid at any cost. So, I mean, it can be challenged by you. It can be you can say that something is not like that, but you know, for example, WTFPL. Do you know what that license is? Like something like what the fuck public license, or do as you want. That is bad license actually, because it doesn't specify the who is liable for anything, and it can be used against you. So, but usually all the good packages are licensed BSD, MIT, and that's it. So just check it. And how you can check it? The simplest way is to parse the output of your configuration or of your package managers. So npm can give you the breakdown on the licenses directly. npm is amazing. NUGET, however, can give you links to the license files, which you can also parse, and you can like search for the names of licenses there. And then having that output, you can have a script that says, okay, please no licenses like this. And then you just pull the plug once something like that happens. I put it on GitHub, my work on how to do that, like just for generating attributions, pulling the plug if the licenses don't comply with the list, and actually checking for vulnerabilities and parsing that. Don't go there yet, because there are lots of new changes coming up. But if you need like a starting point, if you want to start integrating with CI/CD and do all these checks, and before you can just take it and just see, okay, maybe you can utilize this particular code snippet or that part or something like that. So I hope it may help you save some time. It's in PowerShell, just using dev audit and npm as those tools. All right, and now real quick, putting everything together. So how can you improve the security of your dependencies? So locally, you start using package reference, start using npm 6 or higher, install audit.net, and start checking package signatures. For now, just start looking at them. I don't know, maybe come up with the way how to verify them, and don't let any unsigned packages if you can. If you cannot, just check them and later add some sort of plugs whenever the functionality becomes like production ready. In the CI, nice icon, huh? Add dev audit, add dependency check if you can. You can also check npm audit output there. Add attribution generation, that's one from the licenses, so that you have this long attribution file where you says, okay, MIT license for this project, another MIT, and so forth. It can be really long. And yeah, do the checks. So don't let anything GPL like crawl into your products. It will be painful otherwise. And in the public or like deployment-wise, deploy the attributions you generated. It's important, so they are there. If somebody questions that, you can say, no, it was there. Hey, look, you can see them. You can also keep production dependencies list, because at any point of time, it's nice to know, remember the car, it's nice to know what is coming from where and which version of product, of package is exactly there. And very important, review your dependencies inventory more or less often. So just to check, okay, is it the good version to use, or maybe we need to switch. One before the last slides, okay, what are the challenges here? What are the limitations? Well, obviously supply chain management tooling is still immature. I can say that because let's say NUGET got signature verification just few months ago. NPM has nothing like that. NPM audit was introduced just last year. It's still evolving, but it's getting better. It's getting better. Verifying package authenticity, it's still pain a bit. It's not as simple as like with Linux packages, with Linux libraries, with the when you do like yum install. It's better there. Yeah, automation around the dependency management requires specific efforts, and sometimes you have to write entire scripts to just parse NPM outputs, and then they change the output format, and you're like, come on, and they still don't bring the functionality you were after. And finally, it's always battle between control, new features, and maintainability of the project. So decide what's your strategy and just go for it. Okay, that was it. I wrote this, thanks. Yeah, I hope you liked it. If you have any questions, feel free to ask. Yeah, thank you.